Hey friends, welcome back to the channel. And in this video, let's discuss how we can scale our web tier. So basically, we'll be discussing about three main points, which are stateless versus stateful architecture for our web tier, how we can have multiple data centers so that we can scale it horizontally, and the message queues so that we can decouple some components and scale them independently. And the first step is going to be to move the state data out of this web tier. Now, what do I mean by state data? For instance, we can just take it as users session data whenever they are visiting our servers. So the stateful architecture and stateless architecture, let's discuss about that. Now consider this stateful architecture, and there's some user A which has come to our server, which is server 1, and it has the session data for user A. Similarly for user B. Now the problem here is going to be whenever we have a user A coming to our servers, it must be directed to the server 1, because if this request is directed to our server 2, it will not have the session data for user A. Hence, it will not be authenticated and user A will won't be able to access. Now, to solve this problem, we have something called as the stateless architecture. Now, in this, what we have is we have a separate shared storage. And for our example, we have the session data for all the users, and we'll be storing all that session data for each users in our shared storage. Now, this can be any relational database or Redis or NoSQL. And NoSQL is used because it is easy to scale. Now, in this case, what will happen is user A and user B will send their HTTP request directly to any of our servers. And whenever any of these server get the request, it is going to query our shared storage for the session data. And if the authentication is successful, we are going to serve our users. Now, for our case, we'll be using stateless architecture because of its easiness and how easy it is to scale. So our system is going to look something like this. We'll have this shared storage for the user data out of our web tier, and this is how our system is going to look like as of now. Now, now consider when your website or application is scaling more and more, and like there's ton of traffic on your website. So in this case, there are you need to scale basically more. So for that, we have something called as the data center, in which we'll have multiple web servers and their database and cache, and we'll have a shared storage we'll be using for the session data and all. Now, when we are talking about a ton of traffic, we can have this traffic across the globe and from different geographies. So for that case, we need to have multiple data centers across different geographies. So consider this: we have this data center as of now in India, and this data center for the US. Now, in this case, there are certain things that we need to consider. First is the single point of failure. Now, before that, if we had a single data center, if this connection goes down, we won't be able to keep our website running. So in this case, what will happen is if either of the data center goes down, we'll direct the whole traffic to the other data center. So consider this data center 2 goes down, will direct all the traffic to our data center 1. Second point to consider is the traffic redirection. So, consider we have these data centers in different geographies, and how we are going to distribute our data. So mostly it is going to be based on the geographies because of the lower latency. And for that case, we'll be using a GeoDNS, which is going to help how the traffic is distributed among the data centers. Third is the data synchronization. So here we have first data center which is serving to let's say Asia traffic, and the data center 2 which has the US traffic. Now, the local users will have their data saved in this database. Now, if this goes offline, we'll have to redirect that traffic to our Indian servers here. But when someone from the US is going to query the database of our Indian servers, they won't have that data. So to solve this problem, we need to consistently synchronize our database across different geographies so that we don't have any redundant data with us. And the fourth is test and deployment. And to keep our services consistent across different data centers, we should adopt some kind of automated deployment tools so that we can keep our website consistent across different geographies and different data centers. Till now, we had discussed how we can scale our web servers with the stateful and stateless architecture, how we can scale further with the data centers across different geographies. Now, to scale further, we need to decouple different components in our system, and for that, we need message queues. So, message queues is a simple and durable component that is mainly serves as a buffer for some kind of asynchronous requests. So consider this: we have some kind of producer which is going to publish some kind of messages in our message queue, which will have multiple messages across it, and it is going to send it to the consumer so that workers are going to work on it. And when the work is done, they are going to subscribe or send that to back to our message queue. So for example, we as a producer, we have a, let's say, image background removal service. So for that, we have multiple users which are going to publish their requests, and we have multiple messages. This is going to be consumed by our consumers. So consumer is so some kind of business logic that you might have written specifically for the image background removal thing. And when it is done, you are going to subscribe that back to our message queue. Incorporating this message queue into our web tier or our data center is going to help because we can independently scale both the producers and the consumers or the workers that are working on our message requests. So if we have if we have lots of traffic or lots of requests, we can increase our workers, scale it independently so that there are numerous workers who are going to work independently and parallelly on our message requests. And if we don't have that many requests, we can easily scale down our workers. So this is in the end is going to look how our web tier is going to look like when we are going to scale it. So this was the whole discussion about the web tier scaling. As our traffic grows, we need to scale our database as well. So in the next video, we'll be discussing how we can scale our database, that also and how we can scale it horizontally. So that's it for today's video. See you in the next one.